few because I can't obviously snip them all in. Some basics, things you probably already know is that pH plus POH has to add to 14.
Yeah.
And the pH dictates whether it's an acid or a base. You probably know that acids are from 0 to 7 and bases from 7 to 14.
Mhm.
And then probably the only thing is like, how do you calculate the H plus and the OH minus? Do you remember that calculation?
Not really.
Okay. So I'm gonna get the formula. It's a log, it's a base 10, it's some stuff like that. Um, there's kind of a nice chart here. I don't know if you like charts, but let me snip in a picture. I guess we'll start with this. So it's the three things I just said. There's only three formulas. I already gave you one of them. So here's the others.
Yeah.
So the pH plus POH gets to 14. pH is minus the log, and that's base 10 of the H plus, and the POH is minus the log base 10 of that. And if we need to work these backwards, which occasionally you have to do that, the concentration of H plus ions is 10 to the minus pH value. The OH minus concentration is 10 to the minus POH. These are the only calculations you need for this table. So it really depends what they're giving you, how you decide to proceed. Okay.
Mhm.
So let me do this a little bit differently here. Let me just grab the snip of what we want. Just a moment here to get kind of this all so that it makes this easy on us. Okay. So the top row, and then the one that we're interested in, you're on row, we'll say 4. Okay, so they're giving you the OH minus,
Mhm.
which means you can find the POH. You can, because the only formula you have is for POH, you have to take minus the log base 10 of this number. So
Mhm.
do you have a calculator available for that?
I do not. Is there like an online one maybe?
Yeah, let me drop one in the chat here, because obviously you'll need to do this on your own. Or do you have a TID 384 in the classroom or something you can use when you get to school?
Yeah, we have calculators on there.
Fantastic. So this one, you may have to hit the func button for function to get log, or you type log.
Mhm.
Um, it's pretty intuitive. You just type it the way you see it. I'll snip that in here as well. Would you go ahead and type that in and let me know what you come up with?
Yeah. Hold on. Okay. So I do negative log. Where's
Sorry.
the negative sign?
So you can either type a dash or it's the subtraction symbol. Yeah, okay.
Um, and then do I just type in log or?
Yep. Yeah, just type it in. Minus log
Mhm.
5.2 times 10 to the minus 4.
1.2 times 10. Um, it says one element list in the thing, like in the answer area.
Are you using the Desmos Scientific?
Yeah.
Okay. Um, okay. So like, did you type exactly what's written here?
Yeah, a negative log 5.2 times
times 10.
10 to the negative 4.
Okay, and do you have a number to the right over here?
Hold on, I'm trying to find the. I like lost the zoom. It's not on my screen anymore. Oh, there. Okay.
There should be a number like and I'll just snip it in here.
Oh,
This is what I'm trying to get you to give me that number on the right there.
um. Yeah, I think I just did the parentheses wrong or something. I don't know.
Okay. Could you try getting it to like this so you can see the number? Because we're gonna do a lot of calculations like this and
Yeah.
it'll be very, very
Okay,
helpful to
I
have.
got it.
Fantastic. So let's go to 2 decimal places. That's just my preference.
Mhm.
Okay. So like some students want like a mapping and like we're going there first. And
Mhm.
then from there, we're going to find the pH
Mhm.
because pH and pOH add to 14. So I want you to take this number and subtract it from 14.
Mhm.
And give me the result, please.
Okay. 10.72.
10.72. And then there's another mapping here to H plus. Now to get H plus, we have to go back to our formulas here. H plus is 10 to the minus pH. Okay.
Mhm.
So to get that value there for H plus, it's 10 to the minus 10.72. Can you go back to that calculator? You can hit enter to go between lines if you want to keep the previous results.
Mhm.
This one is in scientific notation, so it's going to have a times 10 to some power.
Oh wait. I got 1.9 times 10 to the negative 11.
Perfect.
Yeah.
Very good. All right. So the decision here, acid base. Oh, I guess you have neutral as well. So if it's pretty close to 7. This one
Mhm.
is not. This appears to be a base.
Mhm.
Okay, we're gonna do another one. I don't want to just make you think we won and you got it.
Yeah.
The next one will go a lot faster. So I'm gonna go to row something. Let me get where I've got that in front of me again. All right. So let's go to the next one that's partially filled out. All right, so here's what you've got. You've got pH, and then you calculate the pOH. So H plus here is not correct. We're going to do that. So the H plus is 10 to the minus 5.8
Mhm.
to find the H plus. And then similarly to find the OH minus, it's 10 to the minus 8.2.
Mhm.
So go ahead and calculate those for us, please.
I got for the first one 1.58 times 10 to the negative 6.
Okay, so just go to 1 decimal place. So we'll call it 1.6 times 10 to the minus 6. And go ahead and do the same for the other one.
Mhm. 6.3 times 10 to the negative 9.
Probably correct. Maybe. Yes.
Okay.
Okay, so this one's not too bad. Let's go to the next one here. And the next one I'm seeing is they just give you the H plus.
Mhm.
So you have to, the only place you can go here is to the pH
Mhm.
with the H plus. Okay, and it's the same formulas we're using. It's minus log of 8.6 times 10 to the minus 6.
Okay. Okay.
Let's go to 1 decimal place on this one.
Okay. 5.
A point. So
Um,
it is 5.06. What does that round to? The
yeah,
6 causes
just 6 then, or 5.1.
5.1, yeah. And so from pH, you can go to POH because the two have to add up to 14.
Mhm,
All right, so go ahead and subtract from 14.
mhm. 8.9.
Okay. And then we can decide here, is it an acid or a base or neutral
It's an
based on the pH? Yeah, looks like
acid.
it's an acid. Yep. To find OH from the POH, really you want to think of like them being grouped together. It's like these two are grouped together, and then the POH and OH minus are grouped together. It's either a log or it's a 10. In this case, it's a 10 to the minus 8.9.
Mhm. So 10, 10. 1.2
One
times
decimal place. Is it 1.2 or 1.3?
1.3.
Okay, times 10 to the minus 9.
Yeah.
And you got it there. Okay. All right, so next one here. Let's go to, let me grab the snip. All right, so we're gonna get rid of that number there.
Mhm.
Um, I don't know where your instructor kind of says the neutral begins. 6.5 and 7.5, they're close to 7. Did you get any guidance on that?
Let me look. I think if it's like equal to like 7 exactly, that's neutral.
Yeah, sometimes they give you a little margin of,
Yeah, no, I think it's just if it's 7, it's neutral.
okay. All right. So the to go from the pH to the H plus,
Mhm.
do you remember if it's log or the 10 thing?
It's log, right?
This one is 10 to the minus 6.5. The other one is 10 to the minus 7.5.
Oops. Okay. 6.5 is 3.1 times 10 to the negative 7.
Okay. And how about for the other one?
Um, 3.1 times 10 to the negative 8.
And then acid or base for this one.
It's acid.
Yeah. Good. All right, let's keep going here.
Mhm.
Okay, this one kind of like when we did earlier, when you're given the OH minus, you have to immediately find POH. To do that, it's minus log 1 times 10 to the minus 7.
Mhm. Okay.
You have a number for me?
Yeah. Let me. -7.
Just remember, there's a negative in front
Oh.
of the log down here.
Yeah, I put that in the thing.
The answer is never negative for POH and pH. Did you put -7 up here in the exponent?
Oh no, whoops. Okay, there we go, just 7.
Yes.
Okay.
What does that mean for pH?
7.
Good. And then you can do 10 to the minus 7, or you may realize that it is the same 1 times 10 to the minus 7, like that.
Mhm. And then it's just neutral, right?
It is neutral. It's the one I was looking for. I was like, well, they've got to give her a neutral one at some point.
Yeah.
All right, let's do a couple more here. Let's see, next row, they give you just make sure. Oh, I can see we got to do that one. All right, so next row, we'll have to change some of the values that are here.
Mhm.
Okay, it is not an acid. That's because
Yeah.
it is a base this time.
Mhm.
And then to find the H plus, it's 10 to the minus 9.2, and the OH minus, it's 10 to the minus 4.8.
Mhm. Okay, I see. Okay, so um, 10. Oops. Oh my God. Okay, 6.3 times 10 to the negative 10 for 9.21.
Okay, and for the other?
Um, um, 1.6 times 10 to the negative 5.
So notice that it's kind of the same pattern. If you're going from pH to H plus, POH to OH minus, you use the 10 thing. But when you go backwards, when you go from OH minus to POH, H plus to pH, use the log.
Oh.
And that's what you'll have to remember for the test. You know, at some point you need enough of these and you figure them out, but that's the thing here. So, okay. So to go the other direction, to go to the left here, you have to use the minus log 2.4 times 10 to the minus 9.
Okay. Um, negative. Okay, 8.1. I mean,
Okay,
8.6.
0.6, it's good. Now, what do you find next? Do you find POH or OH minus?
Um, uh, POH.
Yes. And how do you find it?
14 minus 8.6.
All right, so that's 5.4.
Yes.
And then to go to the OH minus, it's 10 to the minus 5.4.
Uh-huh. 3.4 times 10 to the negative 6.
Okay, good. And is this an acid or a base?
It is a base.
It is a base, I agree. All right, let's do one more. I don't know, is there any more on this page that stand out to you?
No, I understand how to do them now.
Let's just do let's do the last one then. Just
Mhm.
then I'll let you
Mhm.
kind of work on that. The hardest ones are probably going backwards with the logarithm, because you got to do both calculations after you find the POH. Then you got to find the pH, and then
Mhm. So, okay, so is the H um
POH.
or well the H is 12 point. Wait, no, that's not right.
Yeah, you first have to calculate POH.
Oh yeah, okay, the POH is 12.1
Okay, and then you go to pH.
pH, which is 1.9. Wait,
Okay.
yeah,
Yep. And then it's 10 to the minus 1.9.
yeah, okay. 10, oops. 10, 0.1. Wait, how is that?
Yeah, I mean it's not sometimes you do get numbers that aren't all that bad.
So I got like 0.0125.
Yeah, and that's okay. So that's you can 0, 1, 2, 5 or 6 if you're rounding.
Mhm.
Yeah, that's okay.
Okay.
Is
And
this an acid or a base?
acid.
Acid. Okay, very good. All right, so on to the other page there.
Yeah.
Molarity, which
Mhm.
feel like you would have covered by now in the course. But here it is right in front of us. You might need a periodic, yeah, you probably will need your periodic table for this.
Yeah, I have one.
All right. All right, so seawater contains roughly 28 grams of NaCl per liter. You want to calculate 28.0 grams NaCl to moles. You're going to have to find the molar mass of NaCl and use that to convert to moles.
Mhm. So And then, so, oh, so grams of Ni or Na 22 plus.
What did you get for your molar mass of NaCl?
58 point, oh wait, yeah, 58.5.
Okay. And that's 1 mole NaCl.
Mhm. I got 0.47.
Okay, that's fine. That's moles. Now molarity is moles per liter, and it already was in liter.
Mhm.
So this is your molarity. It's 0.47 moles per liter, sometimes written as just M, big M for molar. All right, any questions up before we move on to number 2?
No, I think I get it.
Okay, so these are all about getting it into moles or liters or both.
Mhm.
So here's a new problem. They're giving you 5.3 grams of sodium carbonate or something like that, but it's in 400 milliliters this time. So we have to convert that 5.3 grams of Na2CO3
Mhm.
to mole.
Okay.
So that's probably the hardest part, is getting the molar mass of this. Of this.
51, I think.
There's 2 sodiums, 1 carbon, and 3 oxygen.
2 sodiums. Oh yeah. Um, plus 1 carbon plus 3 oxygen. 106.
Yes, I agree. So go ahead and calculate that.
Um, 5. 0.5. 0.05.
Okay, give me a couple more decimal places.
Oh, it's only showing 5.
Okay, let me double check this then. Okay. Yeah, sorry, I guess it is. That's 0.05. Okay, so that's moles, and then you need liters. Now it's milliliters.
Mhm.
You have to convert how many milliliters are in 1 liter. So it's a conversion thing from
Mhm.
before. There's 1,000 milliliters in 1 liter. So
Mhm.
this will equal 0.4 liters. And then to find the molarity, you take 0.05 and divide it by 0.4 moles per liter. And go ahead and let me know what that becomes, please. That
Um,
calculates to.
0.125.
Yes, 0.125 big M. All right, very good. Keep going here. It's going a lot better than the last time I helped you. That's for
Yeah.
sure. Got lost.
Yeah.
All right. It says, how many moles are there in Na2CO3 in a 10-liter of 2 molar solution? So this is a working backwards problem finally. So we know that 2.0 molar is some number of moles per some number of liters.
Mhm.
And we're given 10 liters. How many moles is that then?
Um,
Basically, what number divided by 10 gets you back to 2?
oh, 5.
5 divided by 10 is 1/2.
Oh,
Let's try again here. You can also solve this equation. 2 equals x divided by 10. You could solve for x by clearing the 10 on the bottom.
oh, so 20?
20, yeah.
Mhm.
So x is 20. X is 20 moles.
Mhm.
That's it. There's nothing else to do there. Okay, number 4. How many moles of NaCl are contained in 100 milliliters of a 0.2 molar solution? So 0.2 molar is again moles per liters.
Mhm.
Are we given the number of liters up here?
No.
No, we're given milliliters. So we have to convert milliliters to liters. How many milliliters are in a liter?
1,000.
1,000. So how many liters do we have here?
Um, 0.1.
0.1, yeah. And then we don't know the number of moles.
Mhm.
So just like the last problem here, could you solve this for x? And again, if you need to, you can write it as the equation
So,
0.2 equals x divided by 1.
um, would it just be, um, yeah, I don't know, because,
How did we solve the previous problem? What did we multiply both sides by?
oh, 10, so
10,
then,
because 10's on the bottom. And
mhm,
then same thing here. You multiply both sides by the number that's on
mhm.
the bottom.
So then is it just 2?
You're multiplying both sides by 0.1.
Mhm.
I always recommend going to a calculator,
Um,
especially if you're allowed to use it. If this were multiple choice, your answer would be there and it would not be correct. It's always good to use the calculator.
so just 0.02?
Yes, like that. And that's moles again, moles of NaCl.
Mhm.
So I think the moment you feel like you've got it, they switch it up and give you a new style of question here.
Mhm.
That's number 5. So it's related. It's just that there's a bit more work to do. Like I said, as soon as you get comfortable doing like the calculation one way, you get another. All
Yeah.
right, so it says this time instead of finding the moles, it wants the weight, the grams.
Mhm.
So it's a 2 molar solution.
Mhm.
That's some number of moles per liter. They're giving you 750 milliliters. You have to convert that to 2 liters.
Mhm.
So there's 1,000 milliliters and 1 liter. So that becomes 0.75 liters.
Mhm.
X is the number of moles. So could you quickly calculate that for us, please? How many moles?
Yeah. Um, so 1.5.
So 1.5 moles, and we would be done in the previous problem,
Mhm.
moles of H2SO4. But now you have to convert moles to grams using the molar mass of H2SO4. So 1 mole H2SO4 is grams H2SO4.
Mhm.
So you have to go to your periodic table and determine the molar mass.
Let's see. 98.
98.
Mm-hmm.
So go ahead and multiply 1.5 times 98, and that will be your final answer.
147.
147 grams of H2SO4. All right, let's is this perhaps something from earlier in the course that just to get caught up, or is it stuff you're currently working on?
This is what we're doing right now.
Interesting. Okay. All right. Well, here we go. A couple more problems here. It says what volume in milliliters of a 12 molar HCl solution is needed to contain 3 moles of HCl? So you start with the 12.0 molar,
Mm-hmm.
and it's moles on top, liters on the bottom. They tell you it's 3 liters. I'm sorry, 3 moles, and you have to find the number of liters. Okay. To solve this problem, it's a little bit different than the previous ones. I'm going to go ahead and just write the numbers here. 12 equals 3 divided by X. Do you remember at all how to get a variable out of the bottom?
No, or yeah, no.
So there's 2 approaches. One is to cross multiply.
Mm-hmm.
Okay, that's approach number 1. The other is to multiply both sides by the variable X. Do either of those seem familiar to you?
Yeah.
Which one do you prefer?
So then would it be 12x equals 3?
Yes,
Okay, yeah.
but you're not done.
Mm-hmm.
You've got to get X by itself. You have to divide by 12.
Yeah. 0.25.
Yes, X equals 0.25. Now it wants the answer in milliliters, not liters. So you have to convert your answer, which is in liters, 0.25 liters times how many liters are in a milliliter, or how many milliliters are in a liter, right? Like which way is it? Is there some number of liters in a milliliter or some number of milliliters in a liter?
So is it 250 milliliters?
So there's 1 liter, there's 1,000 milliliters. So yes, there's 250 milliliters. All right, number 7. What is the molarity of a solution made by dissolving 20 grams of H3PO4 and 50 milliliters of solution? Notice you don't have moles or liters, so you have to do the 2 calculations. you have to first convert the 20 grams of H3PO4 into its using its molar mass into moles H3PO4 grams H3PO4. So you have to use your periodic table again.
Mhm. H. $98 to 98.
98 grams. Very good.
Mhm.
And go ahead and calculate the moles here for us.
0.20.
Okay, 0.20 moles. And then we have to convert 50 milliliters to
Mhm.
liters.
Um, 0.05.
So now you take your moles, 0.2, your
Mhm.
liters, 0.05, and divide.
Point two. 4.
Or molar, yes.
Okay.
All right. Last one is really similar. Again, you've got to convert the given quantity into moles or liters or both. In this case, it's both.
Mhm.
So you start with that 12 grams NaOH, and then you need the molar mass of NaOH.
Mhm. Um, 40.
Okay, good. Go ahead and divide.
Mhm. 20. 03 or point 3.
Okay. And then from here, you're going to convert the milliliters into liters. So there's 1,000 milliliters in 1 liter.
That's just 250 milliliters.
Yeah, 250
Or
milliliters, but you dividing by 1,000 to get it in liters.
so 0.25.
Yes.
Okay. And then
Then you divide 0.3 by 0.25.
12.
Should be around 1.
Yeah.
0.3 divided by 0.25.
Yeah, my calculator's probably messed up. Yeah, 1.2 or what? Yeah, 1.2.
Very good.
Okay, yay.
All right. We've got a couple minutes left here. Would you like us to do anything else for the lesson tonight?
No, that all makes sense now.
All right, I'll go ahead and stop here.